So with regard to the second exercise, z is equal to -1 minus I root 3. So this is a complex number which has got real part and imaginary part. So what is the real part? Real part is -1. Imaginary part is minus root 3. Okay, including the minus. So any complex number is of the form a plus ib, where a is the real part, b is the imaginary part. Supposing they ask you to find the magnitude of this complex number, it's root of a square plus b square. That's the formula. Okay, a square plus b square is the formula, which means basically to get mod of z, you should take a plus ib and multiply it with a minus ib. And you know this is I square b square, it will be -1, so it's a square plus b square. In order to get a square plus b square, you're able to, in order to make a plus ib into a square plus b square, multiplying with a plus a minus ib. Just get to know that, okay? Multiplying by its conjugate, okay? But anyway, you don't need that now. To find the magnitude of z, is root of a square plus b square, which means z into z bar, which is a plus ib into a minus ib, is a square plus b square. Therefore, you can call this as magnitude of z the whole square is a square plus b square. And therefore, magnitude of z is root of a square plus b square. So the z, so you get a new property, z into z bar is mod of z the whole square, which is a square plus b square. Okay, so just get to understand that, and let's go to next thing. So to do this exercise, the second exercise, we know the x-axis is going to act as a real part and the y-axis is going to act as an imaginary part, I. Supposing a complex number, the first question is z is equal to -1 minus I root 3. Both of them are negative. This is also negative, this is also negative. So both the real and imaginary are negative. The complex number is present in the third quadrant. And argument. What is the argument? Argument that is the angle that the complex number makes with the x-axis, the positive direction of x-axis. Supposing it is 1 plus root 3i, then it's first quadrant. -1 plus root 3i, then it's in second quadrant. It's -1 minus root 3i is in the fourth quadrant. It's +1 minus root 3i is in the third quadrant and fourth quadrant respectively. So you can identify what is a quadrant. Normally argument is angle that this makes with the x-axis. Now this one making with x-axis is argument theta. So in that case, let's find this angle alpha and do pi. Theta is pi minus alpha. You understand what I'm saying? Supposing it's in the second quadrant, this is the argument theta. Let's find alpha using the opposite and adjacent, x coordinate and y coordinate. And you can do theta is equal to pi minus alpha. Supposing you have complex number which is both real and imaginary part to be negative, the angle it makes with the x-axis is in this direction and it's minus theta. So you find alpha. This is alpha using tan alpha, which is opposite by adjacent, and hence you can find alpha. And to find the argument theta is pi minus alpha. Of course, you need to write it with a negative sign. It's minus of pi minus alpha. So this is, and what about the fourth quadrant? This is your theta argument, but it's in this direction, so it's minus theta. But we want alpha. You can find alpha using tan alpha is equal to b by a, opposite by adjacent, and write theta is equal to minus alpha. So let's look at sums and then you will understand better. So let's go to the first question. Z is equal to -1 minus I root 3. And this complex part is here. And theta this is theta, which the angle makes with the positive direction of x-axis. Or I can do this as minus theta in this direction with x-axis. And theta is equal to pi minus alpha. here it's still theta, so minus of pi minus alpha. So what is alpha? Let's see, what is alpha? What is on the adjacent side? A plus IB. A is adjacent x-axis, which is 1. Root 3 is B, which is from the y-axis. And tan alpha is opposite, which is the y-coordinate, which is minus root 3. By the x-coordinate minus 1, tan alpha is equal to root 3. When will tan be root 3? Tan will be root 3, it's 60 degree. Alpha is 60 degree, or a pi by 3. Immediately plug it in here. Minus of pi minus pi by 3 is minus of 2 pi by 3. And that's my argument. That's my argument. Angle that makes with the positive direction of x-axis. Okay. So this is your theta, which is called the argument. We found the argument. Next, what can I find? I can find the magnitude of this complex number by root of a square plus b square, which is nothing but root of 1 square plus root 3 the whole square, which is 1 plus 3. So it's 2. Magnitude cannot be negative. No? Magnitude means it's like radius or the length or whatever. So it's just root 2. So this is what is meaning of modulus, and this is what is called argument. So you understood how to find the modulus and the argument of the complex number. Let's go to the next question. Minus root 3 plus 1i. Where is this quadrant? X is negative, pi is positive. Second quadrant. This is theta, which is called the argument. You can only find alpha, and tan alpha is equal to b by a, modulus of b by a. Yeah, we don't want negative, it's modulus of b by a. In fact, here it got cancelled, but still, you're taking just b and a and dividing just opposite, because it's an acute angle, it can't be negative, right? So what is b? A plus ib. B is 1 by root 3. Don't take the negative sign because you want smaller angle, acute angle, always positive angle. What is alpha? 1 by root 3 will come in 30 degree. Pi by 6. Theta is equal to pi minus pi by 6. So 5 pi by 6 is my argument. What about modulus of z? The magnitude of z is root of 3 plus 1 is again 4. So answer is 2. So let's go to the next question. Third question is 1 minus I. They want to write this in polar form. Okay? Yeah. So let's continue. The imaginary axis is negative, but A is positive. A plus IB. So it's in the fourth quadrant. This x coordinate and this is y coordinate. And you know this is minus theta is your argument. Minus theta is the angle. You can find alpha by using tan alpha is equal to magnitude of b by a, which is 1 by 1, which is just 1. Therefore alpha is pi by 4. And you know theta is equal to minus alpha. Theta is equal to minus pi by 4, and that's your argument. And then we want to find the magnitude of modulus of the complex numbers. Root of 1 plus 1 is root 2. And they would have asked you to write in polar form. Sorry, the polar form is nothing but whatever they'll write to r. R is nothing but this. This is also called r, the radius, into cos theta plus I sin theta. That's called polar form. The polar form representation is nothing but r into cos theta plus I sin theta. R into cos theta plus I sin theta. That's the polar form. What is r here? Is root 2. What is cos theta? Cos of minus pi by 4 plus I into sine of minus pi by 4. Do you know sine of minus theta is minus sine theta, cos of minus theta is cos theta. So again, but they are not using this trigonometry formula, they're leaving it as it is to show that the answer is in the fourth quadrant. Okay, so this is called polar form. The polar form basically is r into cos theta plus I sin theta. It's the easiest way to do complex numbers. Okay, so let's go to next sum, fourth question. Minus 1 plus I. negative x coordinate, positive y coordinate. This is theta, this is alpha. Tan alpha is mod of b by a, which is 1 by 1, which is 1 alpha is pi by 4. Theta is equal to pi minus pi by 4, 3 pi by 4. What is mod of z? Root of 1 square plus 1 square, which is root of 2. And r into cos theta plus I sin theta. Root 2 cos 3 pi by 4 plus I sin 3 pi by 4. Very easy way of doing. The teachers would complicate a little in school. This is such an easy way. So let's go to fifth question. Minus 1 minus I. Both are negative. This is your theta, which is negative side. Theta is equal to minus alpha. What is your alpha? Which is 1. Alpha is pi by 4. Theta therefore is minus pi by 4. What is modulus of z? Is root 2. So you can simply write the full polar form for this, which is fifth question. Okay, pi minus pi by 4. Sorry, this is not minus alpha. This is theta is equal to pi minus alpha. Pi minus pi by 4, which is 3 pi by 4. So root 2 into cos 3 pi by 4 plus I sin 3 pi by 4. So sixth question is minus 3. What is the meaning of minus 3? Real part, the complex part is 0, which means it's here, it's on the axis. What's the angle it makes with the x-axis? Is 180 degree or a pi radian. What's the magnitude of it? Root of just a square, which is 3. So r into cos 180 plus I sin 180. And that's all, leave it like that. That's the way you express it. You don't need to find alpha or anything here because you directly know that this point, this vector. So let's go to next sum. Root 3 plus I. First quadrant. But x is root 3 and y is 1, a plus ib. Where a comes from the x-axis and b comes from the y-axis. And here alpha and theta are the same because it's first quadrant. And what is tan alpha is b by a, 1 by root 3. So 1 by root 3 will come in 30 degree or a pi by 6. So theta also is a pi by 6. And what's the magnitude of modulus of this complex number is 3 plus 1 is root 4, so it's 2. So 2 into cos pi by 6 plus I sin pi by 6 will be the answer for this. Let's go to 8th question. 8th question is just an I, which means is 1I, which means is 0 plus 1I. A plus IB. The real part is not there. So which means it's going to lie on the y-axis, the imaginary axis. The angle itself is 90 degree. The magnitude is also 1. So 1 into cos 90 plus I sin 90, or in other words, write it in terms of radian, cos pi by 2 plus I sin pi by 2. That completes the 8th question.